A blue solid with a melting point of 498 degrees centigrade is a poor conductor of electricity. The solid dissolves in water to make a blue solution that is a good conductor of electricity. On testing the solution with sodium hydroxide solution, the light blue precipitate is formed. In subsequent tests, the solution was acidified with nitric acid and a few drops of silver nitrate was added. After this, a white precipitate was observed. Explain how each of the observations above allow you to identify the type of bonding present and ultimately identify the blue solid. This is a 6-mark question. Okay, so I've been a bit kind here in this example of a 6-mark question because I've structured the response you need to make down the side here. I've picked the important bits out of this this writing here that we need to take on board when talking about bonding and then identifying the cations and the anions. So this is a very good example of a 6-mark question, but this is not how you would see it in the exam. It wouldn't say observation blue solid explanation. You would have to pick the observations out of here and then explain them. So I've done this bit for you just to help you. But if you have this sort of thing, you have to do this bit yourself. Anyway, let's go through it. A blue solid. Blue solid. So we've got a coloured solid here. Well, transition metals. This is the bit of core knowledge you need from the specification here. Transition metals form coloured compounds. So the first thing is we're going to say is this substance likely has a transition metal as the metal ion, as the cation in it. Okay, melting point. Melting point is 490 degrees C. Well, that's high. It's not super high. It's certainly high melting point though. So it's not super high, so that takes out any idea this might be a giant covalent structure. It's a high melting point. Well, metals on their own have high melting points, but metals aren't blue, are they? So therefore, the high melting point is likely an ionic solid. High melting point. So we're leaning towards it being an ionic bond, and it is definitely an ionic bond, and we'll talk about why just quickly, because the last clue is the conductivity of electricity. Poor conductivity of the solid and the water in solutions, it is a good conductor. So ionic solids have high melting points because the oppositely charged ions, they're made of ions, of positive ions and negative ions. The oppositely charged ions strongly attract. We could say it's held in these opposite charged ions are held in ionic lattice. Strongly attract in an ionic lattice structure. And the last thing to say here is it takes a lot of energy to overcome these forces of attraction. So now, electrical conductivity. It's a poor conductor in the solid states, but a good conductor in liquid states. So it's definitely ionically bonded, this substance. So in the solid state, the ions. Let's do that there. The ions. It's a bit of a mess, that, isn't it? The ions are held in place. Because the ions are held in place, they can't move, and there's no free electrons, so there's nothing to carry the current. There is nothing to carry the current. Let's say that. Right, the solution's a good conductor. Why? In the liquids phase, the ions, which are of course charged atoms. A current of electricity is a flow of charge. So ions are charged. The ions are free to move. Okay, next one. Addition of sodium hydroxide. So sodium hydroxide, when we add it to a solution of this ionic solid, is a test for a cation. Okay, now there's a number of these we have to learn. They're all on this page in your workbook, okay, and they are going to get tested throughout the separate paper. So here we have addition of sodium hydroxide to these solutions. Aluminium gives us a white precipitate, it dissolves in excess. Calcium, white suspension. Copper, light blue precipitate. So if I recall, that's exactly what this one was. Back up here it says, on testing a solution with sodium hydroxide, a light blue precipitate was formed. Okay, so the addition of sodium hydroxide tells us that the light blue precipitate tells us Cu2 plus ions are present. And last one down here, addition of nitric acid and silver nitrate. Well, that's a test for anions. So back to our page, which we have learnt. You have to learn these, you have to learn them. Adding dilute nitric acid and then silver nitrate, chloride, white precipitate, bromide, cream precipitate, iodide, yellow precipitate. Well, I think it said it was a white precipitate, which suggests chloride ions. So let's just quickly check up here again. It said a white precipitate was observed. Okay, the white precipitate, and precipitate is a solid in the solution, of course, tells us Cl minus, so that's chloride ions, are present. The ionic solid is therefore copper chloride, and if it's Cu2 plus, the formula therefore is going to be Cu, or Cl minus ions. So it's going to need 2 chloride ions to balance out the 2 positive charges, so the formula is CuCl2, and that would be a great 6-mark answer to that question. All these questions and more on aylsham-high-chemistry.com.